Assalamualaikum and hi. Today our group want to discuss about logical reasoning and puzzles. What is logical reasoning and puzzles? Logical reasoning is the produce of drawing conclusion or solving problem using facts, rules, logical process. It enables one to understand situation and deductions based on logical analysis instead of assumptions. Logical puzzles are equations that need logical thinking skill using instead of knowledge from memory. Logical puzzles help develop thinking to reasoning process used as logical rules and deductions. Logical puzzles and reasoning are commonly used in various discrete lines, including mathematics, computing, artificial intelligence, programming, and day-to-day problem solving. That will have 7 notation symbols and meaning use. First, we have conjunction and navigation. Third is disjunction. Number 4 is implementation. 5 biconditional. 6 for all, and 7 is for exist. That's mean someone or not all.
I will present an example of logical reasoning using a famous puzzle called the Triplet Brothers Puzzle. This puzzle helps us understand how logic can be used to identify who is telling the truth and who is lying. Instead of guessing, we solve it step by step using logical deduction. Situation. Let's start with the situation. Imagine that we arrive at an island where we meet 3 brothers, A, B, and C. On this island, every person is either a knight or a knave. A knight always tells the truth, while a knave always lies. The 3 brothers make the following statements. A says that B is a knave. B says that A and C are the same type. C says that A is a knave. Our task is to determine which person is a knight and which person is a knave. So how to solve this puzzle by using logical reasoning? To make the problem easier to solve, we convert each person's identity into logical variables. If a person is a knight, we represent it with the value 1, which means true. If a person is a knave, we represent it with the value 0, which means false. Since knights always tell the truth and knaves always lie, the true value of each statement must match the person's identity. This allows us to use logical reasoning instead of guessing. Okay, next, we write each statement using logical symbols. A's identity must match the statement B is a knave. Thus, the logical symbols is A is equivalent to not B. Meanwhile, B's identity must match the statement A and C are the same type, which means B is equivalent A same with C. C's identity must match the statement A is a knave, which is C is equivalent to not A. Thus, we get the equation A plus B plus C equal to 1, since only one knight in 3 of them. After representing the statements logically, we can compare them with each person's identity and continue solving the puzzle step by step. Now, let's solve these puzzles using logical deduction. First, we look at C's statement. If we test both possibilities, we find that C must always have the opposite identity of A. Next, B says that A and C are the same type. However, we already know that A and C are the opposite. Therefore, B's statement is false, which means B is a knave. Finally, A says that B is a knave. Since we already know B is indeed a knave, A's statement is true. Therefore, A is a knight. Lastly, C says that A is a knave. Since A is actually a knight, C's statement is false. Therefore, C is a knave. So, our final answer is A is a knight, B is a knave, and C is also a knave.
And here is another solution for us to determine which is night and which is nef. So we use the true value table to determine them. And we have three statements, which is A, B, and C. So before this, we have mentioned that if the statement is correct or the person is the knight, we put 1 for it. And if the statement is wrong or the person is the knave, we put 0 for it. So in the column A, B, and C, we have put the 1 and 0 for them. And we also have to calculate the sum of knight. For example, the row 1, the sum of knight is 3. And the second one is 2, and so on. And we also have to look at the A statement. So A says that B is the knave, which is B is not a knight. So B is equal to 0. So we compare the A statement with the column B. For example, row 1. B is 1. Is this same with the A statement, which is B is 0? No, they are not the same. So this statement is wrong. So we put the 0 for it. For example, the row 3. B is 0. Is it same with the A statement, which is B is 0? Yes, they are the same. So we put 1 for it. And we have to look that does A match, which means that does the column A match with the A statement? So let's look at the row 1. The row 1, A is 1, but the A statement is 0. So they are not a match. So for example, the row 3, A is 1, and the A statement also 1. So yes, they are matched. So we look at the second statement, which is B statement. B says that A is same with C. So we look at the A column and the C column. Are they the same? So for example, the row 1, A is 1, C also is 1. So yes, this statement is correct. So we put 1 at the B statement. For example, the row 2, A is 1, but B is 0. They are not the same. So the B statement is wrong. We put 0 at the B statement. And same, we have to compare, does the B match? So does the B statement match with the column B? For example, the row 1, B is 1, and the B statement is also 1. So yes, they are matched. For example, row 2, B is 1, but the B statement is 0. So they are not matching. So we look at the last statement, C statement. C says that A is the knave, which is not the knight. So A is equal to 0. So we compare this C statement with the column A. So for example, row 1, A is 1. Does it same with the C statement, which is A is 0? No, they are not the same. So the statement C is 0, which is wrong. So we look at the row 5. Row 5, A is 0. And it is same with the C statement, which is A also is 0. So this statement is correct. We put 1 at the row 5 for C statement. And we can see that the C statement, the first 4 is 0, the last 4 is 1. Because the first 4 for A is not 0, which is not same with the C statement. And the last 4 is same with the C statement, which is A is 0. Okay. So we also look at is the C match with itself. So we look at the column C and the C statement. So for example, the row 1, C is 1, but the C statement is 0. So they are not matching. And the row 2, C is 0, and the C statement also is 0. So yes, they are matching. And the last one, we have to look at the system. Is the system consistent? Which means that which row have the 3 yes for the A match, B match, C match, which is which row for column A is matched with the A statement, and the column B is matched with the B statement, and also column C matched with the C statement. So we can see that the row 4 got 3 yes for it. So the row 4 is consistent. So since the row 4 is consistent, we know that the A is 1, which is A is the knight, and B and C is 0, so B and C is the knave. So here is the final answer, which, as I mentioned just now, A is the knight, B and C are the knave. So we sum up them, A, B, and C, we get 1 for it. In conclusion, while it is interesting because the knights and knaves puzzles seem like simple linguistic riders, however, they are deeply fascinating with self-referential logic and meta-information. Watching a complex, confusing verbal statement such as a knave lying about what their life would be, cleanly untangled into a basic, elegant binary equation, like 1 or 0, reveals the hidden logic. Besides that, it is important because in our real life, mastering the logic behind these puzzles is what allows us to write a glitch-free programming code by simplifying the messy if-else conditions. And it is how we program the AI agents to make smart, safe choices based on data. It is also the exact math used by logistic software to solve the massive scheduling problems like setting up the university timetables or flight paths without stages by running thousands of constraints through a logical solver in seconds. Ultimately, learning this structured way of thinking stops us from guessing or falling for misleading data, training our brains to solve everyday problems using facts rather than flawed human intuition. Last but not least, it is useful for us because in the area of data science and automation, the principles behind these puzzles are highly practical. For example, artificial intelligence. The AI agents use automated theorem proving to make the decisions for us rapidly. For an autonomous system to navigate an environment safely, it must evaluate incoming data streams that might be conflicting, incomplete, or corrupted. Analyzing these puzzles helps us understand how to program algorithms that extract absolute truths from noisy environments. Besides that, in our daily life, we use the facts and rules to reach the conclusions. It also improves our critical thinking and also the real world problems can be solved. So that's all for our presentation. Thank you.